Hey, welcome back. So we need to make this into a simple hit the target game. It's a game physics course after all. We'll add a cylinder to represent a rocket launcher, write a quick class, in fact you'll do that. So currently we have two balls in the play space like this. Let's get rid of one of them, leaving just the one in the center of the play space. So delete your second ball, your reference ball. Fantastic. I'm just going to give myself a little more space like this. Great, so then looking at the first ball, what do we need to be happening here? Well, I want to make a rocket launcher, so I'm going to go ahead and double click on the ball to focus on it, create myself a 3D object cylinder, and that will go right in the middle of the play space there. And then I'm going to rotate that to 45 degrees, or minus 45 degrees in our case, so that we're firing the ball to the left, which is in the positive X direction. Okay, so that just gives us something to work with. Now, in terms of the collider on this cylinder, it comes with a capsule collider, which is okay, and it's a capsule collider that's been adjusted to be pretty much the same shape as the cylinder, but we want it to be just a trigger collider. We don't want any physics, we don't want to risk any physics happening. And why do we need a collider at all? Because the gameplay that I'm just going for in this very simple game is as follows. We'll leave the camera in a fixed perspective over here. You'll push and hold on the launcher to build up the launch velocity. We'll use a really silly sound, which I've recorded, which goes something like this. And you'll hear that in the supplied asset file. And as you hold the button down, you'll be able to tell from the sound how wound up the ball is. And when you let go, it'll go flying off, exhibiting nice, complex drag in our fluid drag component here. And the idea will be to get it to land over in the goal box. Okay, so that's why we need a collider, because it's going to intercept the click cylinder, which we can rename launcher. Is only going to intercept a click when it has a collider on it. It's just how Unity works. So there's that. Now let's fix the camera. We have a nice camera perspective right here. So one way to adjust the camera is to click on it and say game object align with view. So we're aligning the scene view with the view. And then you can turn off, if you like, just temporarily disable or completely remove the mouse orbit script. Either will have the same effect. Of course, if you remove it, all of these parameters will be lost. So I'm tempted to just disable it. Let's just check that when we play, we get that. That's pretty cool. Okay, so the ball's flying out. And we still want to keep this fluid drag on there. Perhaps we'll put more drag on in a little bit. But we also don't need the rocket engine, because we're not going to launch it using the rocket this time. We know how rockets work. We're just going to try a different way of doing things, which is get the launcher to just give it an initial velocity. So let's remove the rocket engine component. And this is our starting point for this really simple game. Now that we have this ball set up how we want it, why don't we make a prefab of it? So firstly, think about what its name should be. Something like just ball. It doesn't need ball 1. And you prefab it by just dragging it from the hierarchy down into assets. And it will then create a prefabricated version of this ball. And the ball in the scene will become blue, which means it's linked to the prefab. And now that we have a prefab that we can create on launch, we actually don't even need a ball in the scene at the start. The launcher will create a ball at launch time. So go ahead and boldly delete your final ball, bearing in mind that you can always drag your prefab ball into the scene, and you can also have your script create the ball at launch. So I'm going to help you to create this launcher.cs class, but I'm going to leave plenty of it to you as well. So add a component to the launcher, a new script, and just call it launcher. So before I leave you to the challenge of creating the rest of the launcher class, I want to show you how to intercept the click on the launcher, because it's very Unity specific. So we used void on mouse down like that. And just to check that's working, why don't we just debug.log something like launcher clicked. And this will work for touch interfaces as well. And what it's doing is saying that where the person has clicked on the screen, if you were to cast a ray directly into the screen, what do I intercept? And if I intercept the launcher, then we have an on mouse down event on the launcher code. Let's just take a look and see if that works. So we play the game. We're staying in this sideways perspective. Keep an eye on your console and just click the launcher. You see launcher clicked, and I've got a stacked console here, a collapsed console. I can uncollapse it, and it just keeps logging every time I click. We want to continuously increase the launch speed. And then when we release the mouse button, which raises another message called on mouse up, then we want to stop increasing, or just launch the ball basically. So, see if I can type right. So on mouse up, we launch the ball. On mouse down, I'm going to get rid of the log statement. We're going to increase ball speed to max over a few seconds. And those few seconds could be the length of your sound sample. Now, as a hint here, when you actually try and write this, you may here need to use a method called invoke repeating. Take a look in Unity's docs for invoke repeating. And you may want to write yourself another method that says something like void increase launch speed, like that. So the end result is that you push and hold on the launcher, and that over the period of the sound sample, remember I said I provided you with a new asset. If we go import package, custom package, there's two sound assets here. One is one that goes thunk on launch, and then the other is one that is the wind-up sound, which you can see from the sound trace, gives you some indication of how much velocity we're adding. As you hold this button down, we want that launch speed to increase, and then the moment you let go on mouse up, the ball gets launched towards its target. Managing all the sounds as we go. So here's your challenge. You've got the outline that you need. I believe you're ready for the actual challenge. Write the rest of the launcher.cs class. Take in max launch speed as a publicly exposed parameter in the inspector so you can game tweak it. Drag in the two sounds we've provided or make your own, one for wind up, one for launch. Drag in the ball to be instantiated and launched, that ball prefab we just made. The launch speed should increase while the launcher is clicked and held. And then the ball launches when the mouse is released. That's your challenge. You may need to dive into quite a few Unity docs. I think you're ready for it. If you can't do it, don't worry, just keep playing the video, I'll show you how. And if you can do it, congratulations. It's a bit more of a Unity exercise than it is a physics exercise here, but we do want to round this section off by making a complete game. So pause the video, have a damn good go at getting that going now, and see if you can get your ball landing in the goal area. Okay, so welcome back. Let's get this final script written now. So I'm going to start from the top and think about what the launcher class is going to need. It's going to need a public float max launch speed so that we can adjust the game. We also need some audio clips. So we're going to have a couple of audio clips and we'll drag them into the inspector. So we're going to have a wind up sound and another one. You can actually declare two variables on the same line just with a comma like this if they're of the same type. Launch sound. And we're going to have one more, which is going to be a private. I like to put a space before my private variables. Float launch speed, which is the current launch speed that it was set to depending on how long we've held the mouse button down for. We're also going to need to find the audio source that's on this launcher. Now, the moment you type something like that and realize, well, there isn't an audio source on the launcher, go and stick one on. So go to your launcher, add a component, audio. You may have wondered what should make the sound. Good question. Should it be the ball? Should it be the audio source? Well, the hint here has got to be the launcher because there's no ball in the scene at the moment. So we have an audio source. We don't need to play on awake. We also don't need an audio clip because we're going to have two audio clips. When we save this script, the fact that we've said public audio clip wind up sound, launch sound means that on the launcher, look, it's asking in the script here, we'll be asking for two sounds. In fact, let's go get those sounds and drag them in right now. So this is where you import from the custom package or record your own really silly sounds. Just grab the launch sound and the wind-up sound. There's a new folder called Start Pack. There they are, launch and wind-up sound. If you don't like this structure with Start Pack, then you can always just move these folders back in assets like this. And again, with the scripts, you can delete it or tidy yourself up. So find the launcher, put your launch sound and wind-up sound in. So that's how we're making the association. Max launch speed, we'd better give it something. I have no idea, but I'll give it 100. Okay, cool. So we've got all of those things. What else are we going to need? Well, we're also going to need the concept of how fast the speed increases. And that's going to be a float, and it's going to be something like extra speed per frame. And that's every frame that we're holding down, clicked on the launcher, how much extra speed are we adding? Yeah? And then the final thing we're going to need is a ball to launch. Now, we can make that public. I said we'd drag it in. But what type is this thing? What type are we going to find the ball with? Let's go and have a look at our prefabs. Well, the most important thing, the most relevant thing about the ball is the physics engine on it, because it's a physics object, right? So let's just say private physics engine. But in this case, let's call it ball to launch so we know what we're talking about. So it's a variable called ball to launch of type physics engine. So they're all the variables, public and private, that we need. I hope that makes sense for the launcher. It's kind of a sensible API, application programming interface, to the launcher. So now we've got to go ahead and do our component-based architecture stuff. We've got to go find the audio source, and that equals get component of type audio source. There's only one audio source on this launcher, so that's going to be a safe way to find the audio source. We can now set the audio source.clip straight at the beginning here. .clip, and then equals which one? Well, we want the wind-up sound at the beginning, right? That's the first clip we want loaded. And why do we need it here? So we know the length of the clip. So what are we going to do with the lengths? Well, the extra speed per frame is the max launch speed times the time.fixed delta time. Now, I'll explain that in a moment. Divided by this audio source dot clip dot length. So what's that doing? Well, we set the audio source's clip to the wind-up sound. It might be 3 seconds long. So the audio source clip length might be 3 seconds. So over 3 seconds, we want to get to the max launch speed. But it depends on the frame rate. Imagine that the frame rate is 0.1 of a second then. So we have a max launch speed of 10. We multiply it by the 0.1 of a second, giving you 1. And if we divide 1 by the clip length, which might be 3 seconds, then each frame we want to be adding a third of a meter per second in this case. So this calculation basically ensures that it takes the length of the clip in time for the launch speed to go from 0 to the max launch speed, and it will be frame rate independent because we're taking account of the fixed delta time, the frame rate, the physics frame rate, okay? Hopefully that makes sense for you. Okay, fantastic. So now that we have all that, how are we going to actually get this guy to go and fire? Don't need the update method. What we do need is on mouse down, we need to do a few things. The first thing is we need to set the launch speed to 0. Then we're going to make an audio sound, so audio source dot clip equals the wind-up sound. Why are we doing that again? Because we're also going to have a launch sound, and we want to be sure that on the second launch we're still using the wind-up sound. So that'll come clear in a moment. And then audio source.play, which is a method, is going to play the sound. So that's all well and good. Let's try this and make sure we get at least the sounds. In the background there you can hear my ridiculous sound effect. Fantastic. Okay, now let's publicly expose the launch speed for a moment. Just temporarily make your launch speed public so you can see in the inspector that this speed is increasing properly. So max launch speed 100, current launch speed is 0. Watch what happens when I push and hold on the launcher. Watch the launch speed and the max launch speed. No change yet. Okay, so that's obviously not right. Why is it not changing? Well, because we haven't actually written any code to make it change yet. We've just got the structure around the outside of that. So what we're going to need to do is increase the speed in this increase launch speed method. Why in a separate method? You'll see in a moment. But first we need a test, provided that the launch speed is less than or equal to the max launch speed. Now why can't I see max launch speed? Public float max launch speed. There you go. It's decided to autofill it now for me. So if we're not already at the max launch speed, then we quite simply want to say launch speed plus equals extra speed per frame. That's where the increase happens. But it's still not getting called. Increase launch speed isn't getting called. And what we actually want to do is use this invoke repeating method. Have a quick look at Unity's docs for invoke repeating. I got to that by holding down Command and hitting the apostrophe key. And what invoke repeating does is it repeatedly calls a method of a given name, starting after a certain amount of time and repeating every certain amount of time. So, how are we going to use that? Invoke repeating. This is why we need a separate method for increase launch speed. So we can address it like that. Let's give it half a second delay before we start increasing the speed, just for usability. And then we're going to increase the speed every time.fixed delta time. And that's where the time.fixed delta time comes in again. So this time.fixed delta time cancels out with this. So we click the button and it repeatedly calls this method until the speed gets up to the maximum. And then it continues to call this method, but no longer do we add any more to the speed. Let's see that in effect. Click play, click on the launcher, and watch the speed and the max launch speed. And listen to my crazy sound. The moment I get to the end of the sound, there's a bit of silence on the end, we get to the max speed. So that's working exactly how we want. And if we let go of the launcher before the maximum speed, then nothing's happening yet. So we need to go make that work. And that's because on mouse up, nothing happens. So what do we do on mouse up? There's a method called cancel invoke. That immediately will stop that launch speed increasing. Watch this. It will cancel the currently invoked repeating method. And we let go, and it stops. The sound clip's not stopping playing though. So let's stop the sound clip. Let's do all of our things about audio source in one place. Audio source.stop. So we stop the sound clip. What else do we do? Set the audio clip to the launch sound, because we're getting ready to launch, and then we play the launch sound. There it is. Okay, so and the final thing is going to be to actually launch the ball down in here, down below. But before we do that, let's check that all the sounds work properly. There you go, Tobias's fantastic thump. And let's check it works on a second run. Great. Okay, so now we can fire off multiple balls, which is going to be great. Fantastic. Final thing then. Let's get this ball actually being instantiated and fired. So how are we going to do that? Well, we're going to make a new thing of type physics engine. It's going to be called new ball. And we're going to use the method instantiate. Then the ball to launch, which we dragged in the inspector. But we need to cast it to a physics engine. Otherwise, it will create a game object or a Unity object. Well, let's see the error. Here you go. Let's take that cast off the end and build. Here, build all. Cannot implicitly convert type Unity engine object to physics engine, because by instantiate returns an object. So we need to do something called a cast into game object. Sorry, into physics engine. The clue's at the beginning of the line. Fantastic. Now we do things with a new ball. Now that we've got a variable, we can do things with it. New ball.what? .transform.parent equals game object dot find. I'm just going to launch. I'm going to parent all balls into something called launched balls. Now this is good practice when you instantiate multiple things. Let's go into the Unity inspector, create an empty object, and call it launched balls, and reset its transform. And that means all the balls we create will be parented or childed under launched balls. Okay, and that's just a neat thing to do. If you change its name, though, beware that we're finding it by name. And it's not just the launch balls itself, it's the transform we want. So the new balls parent becomes this launched balls transform, i.e. this thing here. Great, so that will parent new balls as they get... Well, let's just do it, actually, before we move on. Make sure we're small chunks, right? Let's make a ball. Instantiates a ball. Now, the thing I want to instantiate is null, is the error I'm getting. So look at your launcher. It's because we haven't given it a ball to launch. So here's our ball to launch. Drag it in. Try again. Perfect, look, the launch balls are here. Okay, fantastic. So the final thing we need to do, of course, is just give them some velocity. So let's store the velocity, launch velocity, and it's a new vector 3. And it's at 1, 1, 0. It's at 45 degrees xy. Dot normalized, which makes the length of that vector, instead of 1.4, or the square root of 2, it becomes a unit vector of length 1. So then when we multiply it by the launch speed, we get a vector that's in the correct direction, i.e. 45 degrees, at the launch speed. Finally, we just do new ball.velocity vector. Now, velocity vector is our physics engine's velocity vector equals the launch velocity. Take a look at that code and absorb it. Make sure you're happy with how it works. In the next video, we will stop the ball launching off into space and refactor the rocket engine, as I said, and we will be done. So see you soon.